Greetings and welcome to this tutorial on lack of fusion and hotspot analysis. As explained more fully in the overview video on this topic, we use lack of fusion and hotspot thermal analysis to identify regions of a build that might not get hot enough to fuse properly, and areas that might get too hot, resulting in oxidation or evaporation of material. In this tutorial, we will first discuss the process parameter or PRM file that supports this type of thermal analysis and the settings required. Then we will run an analysis at the part level and briefly interpret the results. To review the PRM file and its settings, on the Home tab, click Processing Parameters. Note the icons in the library to differentiate the stress and distortion PRM files, as shown here, from the ones for lack of fusion and hotspot analysis, as shown here. The PRM files provided with the software, however, are of the combination type for running both types of analysis, stress and distortion, as well as lack of fusion and hotspot prediction. If I click the New button, I see the familiar settings on the Physical tab, and also an Analysis tab added in Release 2018.1, which is where to specify settings for the type of PRM file to create. I can select stress and distortion, or hotspots and lack of fusion, or both. If I choose hotspots and lack of fusion, then I can specify values below for lack of fusion, hotspots, and interlayer temperatures. To start our analysis in Simulation Utility, we click Machine on the Home tab to select a PRM file. Choose one for Inconel 625, either the combination type or the lack of fusion type. Click OK, click Solve, and when possible, load the results. Notice that the three results are familiar from temperature settings in the dialog for creating a new PRM file. Just to make results more visible, I'm going to right-click a result, select Render Properties, and turn off Element Edges. When we look at hotspot volume percentage, we see that the highest percentage, over 98%, are in the thickest part of the build. When we view the interlayer temperature results, to see the temperature of each layer before the next layer was deposited, we see the highest temperatures again in the thickest part of the build. Finally, we can look at the lack of fusion volume percentage and see a prediction of no lack of fusion in the build. In summary then, we have discussed the process parameter settings that support the thermal analysis of lack of fusion and hotspots. We have run an analysis at the part level and briefly interpreted the results.